Hey, Radhe Radhe, hey everyone. Um, right, so we are like, let me see if my network is stable right now. All right, so today we'll try to explore more about the Redis. We'll try to see if there are a lot of different, updates recently in the Redis software. For those who doesn't know as much about the Redis, it's a database application. It's a software that uses the in-memory data storage of different data structures instead of just storing different kind of features and different uh, data in form of rows or columns. It instead kind of stores the whole data structure of your application or different sources uh, in memory, in the cache, in the form of over the RAM of your device, so that you can have fast access. The whole the time complexity will also be O of one, that is constant, so that's why it's a lot faster. It's a less complex whole structure, as well as also it prefers to keep the single threaded. It's a single threaded instead of being a multi-threaded kind of a software. In multi-threading, you might observe a lot of race conditions as well as a lot more complexities while engaging along with the logs and syncs and a lot of other things. So that's why it's been kept as a single thread software instead of going along with the multi-thread environment. It store everything in memory. That means it will be storing everything primarily on the RAM of your environment. So that's why it will be a lot uh, faster comparatively, and compared to the other softwares that are available at the moment. As well as also you might use it for the data structures, storage, and a lot of other things as well, while engaging along with even with your microservice environment as well. So we'll try to look into them. And I've also made I'll also try to make kind of a clone project, not a clone, but kind of an in-memory storage that has been inspired from the Redis structures or the whole architecture. We'll try to grab or get some more features as well, while of managing along with the cache, different kinds of cache. We'll also try to uh, look over the whole documentation of Redis that is available at the moment. For any particular person who doesn't know as much about the whole project, we'll try to look into the whole documentation as well as also some of the books or blogs that I have found earlier on their official site. So we'll try to look into them. All right. Let me share my screen. All right. All right. So is the site. You can also view some of the docs as well that are available. Isn't right, now it is visible. That's the whole project. That is think fast, build faster. That is for AI and LangChain, LangCache. That are some of the features that we'll be looking into. For any particular person who doesn't know as much about building, AI agents as well, will try to look into those particular features as well, because it's handling latencies and better throughput and better, lesser overhead computational power is are also some of the features that we should be looking into in order to integrate other different softwares or any particular framework or tool that is available on our platform. So it is a lot better for the platform team as well, in case they want to have a lot better overview of the whole application. So these are some of the recent updates that has been pushed on the project. That is Redis for AI, that is for lang cache, caching, obviously Redis insights, flex, query engine, and Redis data ingestion as well. So here they are. For a newbie, I'll try, right? I'll try, as I can see in the chat. We'll try to go over the basic features as well of the whole project. Deployment Kubernetes, and these are clearly set up Redis cache primary, vector or custom database, building Gen AI apps with Redis optimize. Let me first connect it all along the along with the cache. I guess it will be a lot basic comparatively, so it will be a better introduction to the whole stack. And anyone who doesn't know as much about Redis, it will be a good idea to first get to know about the application or the software first. Get to know about the building blocks of the whole idea behind this particular project. You might have heard about the Redis a lot if you are a developer or have been working in a developer environment. All right, some kind of problem, I guess. Fine. So that is for AI, then caching. Let's look into caching first. Then later we might look into the data ingestion as well as data engine as well. It is obviously on the processing side of the whole cycle. It is also like as soon the sources or the any particular data has been collected from the sources, it might first get over into the data ingestion, and then later it might load, or either way it get processed for the faster calculations. It you might consider for caching. So yeah, um, real application, real-time applications run at enterprise scale, caching. So everybody does know about caching. So if any particular task is being repeated a lot, so it might be a lot better for any particular transaction to store some of the widely used or repeated tasks in the memory or either in the cache memory. So for any particular solution, so in order to reduce the complexity as well as also reduce the latencies of any particular process that might have been going through, in order to increase the throughput as well, it might be a better option to perform the caching. Right, we have different kind of caching that are being promoted by the software. That's all by the cache side. Query caching, while following a querying kind of a data structure. Right behind caching is integrated CDC. Right through caching and cache through fetching. Let's start with aside, I guess, cache aside. We'll walk through the whole docs so that it might, appear to be a better option for us as well. All right. So any particular person who does, learn about the whole caching that I've been going with Redis, you might consider about giving it a try. They actually have a book. I've downloaded it just now, so let me download it first. I'll add it to the whole summary of this particular live session as well, the Google Docs. If you want to know some of the recent summaries of previous live sessions or the live streams that I did, you might find it in the description as well. Yeah, so let me put it over here. Let me put it on dark mode. Light kind of hurt my eyes. You might have to take this particular topic as well. I've put it from the first live as open telemetry. You might take it in the next live stream where we'll be discussing about the platform engineering as well. So there is about the different certificates that come along with the platform engineering. There is about the platform engineering associate as well as platform engineer, the CNCF and the Linux Foundation as well. So we'll try to cover it in the next live. For now, we'll try to look into the whole recent updates that have been introduced at Redis. What happened? Right. Right. So let me put a link to Redis cache book. It is. I've updated it. If any particular person wants a link to this particular Google Doc, then it is present in the description. You can reach out to the link and just copy it and head on to the particular page that we'll be accessing or referencing in a moment to, you know, get to know about the whole architecture or different, different kind of methods Redis usually gets involved while designing their whole APIs as well as caching environments and methods as well. So, and then later on, I will try to build a whole project that has been inspired by the Redis. Not a huge, kind of the exact copy, but we'll try to build a kind of a backend for the Redis for the whole CLI, request and response kind of a thing as well. It will be including the REST environments and different, air files as well and different kind of things where we'll be accessing around or playing around with the CLI in order to manage our whole requests or the APIs in the form of the REST protocol. All right. So it's slide 7. We'll try to stream next week, I guess tomorrow we can, yeah, maybe. Right, so that was the previous slide. That was the platform engineer core fundamentals. We also discussed it in the live third. And right 4, we tried to look into the CVEs. And now we will try to look into the Redis, exploring Redis recent updates, features, I would say, and reverse engineering it. Yeah. Or why? I put another topic that is for the cache handling. Um, So that one was for caching at scale, I guess, right? Oh, this whole book is for the caching at scale. So it's right, kind of an introduction to the whole caching thing. This we'll try to look at the whole caching uh, PDF as well. I've downloaded it. You can also download it from the web directly. It's been written by Lee Jason. I guess I pronounced it well correctly. A huge shout out to Lee. Yes, introduction will involve the modern demands and why do we need caching. I already told you what's caching. We usually prefer to store kind of a local data or frequently used data in cache memory or the RAM itself or the cache memory itself, so that we can get access to any particular saved or cache memory a lot faster comparatively, instead of going along with the whole cycle of getting or retrieving data from the data centers and going along with the ingestion layer as well, and then processing and everything else. We just and then performing the mathematical functions as well and going along with the whole data structure. You can just store some of the frequently used or frequently requested data in the cache memory itself. Here it is. Request has been sent, then the data service, data cache, and then it will be sent back to the consumer. Different kind of caching techniques that all will be working on and try to get an idea about. I just know about them all. I have also made a particular project about them, but still, for the live, we'll try to get along with the whole. We'll try to learn about the whole thing. Network is unstable. Great. Let me share it once again. Might have been some kind of problem. Interrupted the whole screen share as well. Right. For here we have caching use cases for the HTTP application cache. Whenever you go with the web and ask for any particular request on the web in the form of the web pages or either in the form of the different calculations or processing that you might have done. Whenever you visit, let's say Facebook or Slack or GitHub, then there are different processes that might have been going along on the server, and whenever you ask for any particular service, let's say on these Instagram, there are different cache, or either on the Google as well. When you're looking on the Google on your laptop screen, and when you search Insta and you just put a single thing on the Insta, you might have gone on the the explore section of the Instagram, where you can find a lot of different reels that might have been recommended to you. In it's a kind of an overview or different kind of the reels that you might click and look into. Then that particular the whole address, the URL might be saved in the cache memory of your laptop, so that you can just get over to them. And even on the DNS as well, for finding out the whole address of your application. All right, there's some kind of problem. Good. Um, right. Oh no, it was all fine, I guess. upload speed is all right. What happened? I think there's something wrong with my Chrome itself. I look network looks kind of stable right now. I don't know what's going on. Uh, if anyone's present, yeah. Whenever I have any particular kind of network problem, it will be a lot helpful if any particular person might guide me or might just share the status if it is all going fine or there's some kind of problem that's might have been interrupted the whole stream. Um, yeah, so let's get over to our file. All right. There it is, caching use cases, HTTP application cache. That's why I said even the DNS servers usually have a caching memory for storing HTTP network cache. Page is accessed by a user. The site generating the page very fast. Web browser itself may also cache some content so that it can be displayed almost instantly rather than waiting for it to be downloaded across the significant distances and potential slower network internet link. Right. There are different kind of cache memory that you can find. One of them is the application HTTP application cache and the HTTP network cache, web browser cache, service cache, API cache, and database cache. These are some of the most common one. Even on the whole system as well, you might find the CPU cache. That's all for the OS level uh, memory management that's been going on, and that's the memory cache and disk cache. These are some of the basic things about the caching that are being written over how in this whole particular book. You might consider to look into the whole PDF. They are kind of basic, so I won't be going over them because the Redis is focusing upon something else. So I'll try to look into them. Static and dynamic cache. This one I might consider. So the dynamic ones are the read-write kind of the cache that are being stored, while the static ones are just read-only kind of thing. Whenever you want to change any particular thing, then you might consider, changing the whole thing in case of the dynamic caching. While on the other hand, in the static cache, whenever any particular element has been deleted or decided to change any particular information that has been stored like in a particular with respect to any particular key, like in this particular diagram you might see it's the static is the dynamic cache and this one is the static cache. So here we can see if you want to change any particular thing, then it will like the key is cost and the value is 51. If you want to add any particular thing, then you might cache updates the data store. It might change or store any particular thing. It's being stored in the whole tree kind of structure for the data structures. It's the same key is cost, suffix is 24, and the code here has been saved or implemented as 24. It's been added to your whole tree. While over here, like in case of the dynamic cache, it will be keeping a value. It will be keeping a look over the previous cache as well that has been stored on our tree. While on the other hand, in case of the static cache, if you want to change any particular thing, let's say of the cost, or add a new key value pair, then it will delete the previous cache that was stored and it will jump to the newer one of the cache memory that is being built that will be containing the cost is 51, suffix is 24, and Korea is also 24. Cache can't be updated, so update goes through the data store. That's why I was saying. Static is like you can't update any particular thing. You have to, it's kind of a read only feature that has been provided. While on the other hand, dynamic caches are kind of read write, so you can just kind of store the whole thing, just add it up in the whole tree. Right, that was all about the caching, the introduction, kind of caching. Why do we need it? Now no, it's yeah. Now I guess it will be all fine. I guess that's. Yeah, I mean, YouTube doesn't refresh it. If there's any particular kind of a problem with the network at once, then it might won't start, doing its best, even if the network's stables. For some reason, it will, continue showing the problem. I guess. Yeah. Right. So yeah. Now I'm like, let me share my screen. Document which we were earlier. There is the inconsistent data share, cache data. There are different kind of the problems that you might, kind of experience while caching. There's some kind of, the inconsistencies, as well as also there has to be some kind of precautions that should be kept in the minds of the API developers, or either in the minds of the developers who are designing your API, or either your cache memory, your application, your backend. You have to keep a look over everything. Here they are taking a simple request, simple kind of an example. They are just multiplying different kind of digits. 6 into 7 is 42, 12, and 16 to 12 is 192, 34 is 12. So they are considering each and every particular case, and then they are saying that it might looks kind of, a simple multiplication calculation. So why do we need caching? So they have, kind of just shown why is it important. They have given each and every particular step as well. I don't want to go over there. Oh, yeah, just no, just kind of give a look over there as well. Consult the cache to see if there's any entry representation that is 304. If there's any entry, return the result from the cache stop. There's no entry, then call the service and get the result of 3 times 4. Store the result of the service call into the cache memory until the entry 304, and then return the result. Yeah. So even in each and every particular digits, you might consider calling and storing these in the cache memory, so that even on multiplying between two different numbers, you might call the cache result. You might just consider the cache result that has been shared or stored to our uh, you know application and the whole cache memory, instead of just skipping it and using the computational power to calculate each and every particular thing that is being stored. What happens next? Well, the first time anyone gets the result of 3 times 4, the request has to consult the service directly, because the value has not been shared or been saved, previously being placed in the cache. However, after the value is calculated, the result is placed in the cache memory. Cache now store it. Next time someone wants to get the result of 3 times 4, the result request sees the request is already been stored in the cache, and it simply returns. Even for multiplying two different numbers, that does hold a huge, you know you can even consider of designing a kind of a software in which you will be considering the calculation between the two prime numbers as well. And yeah, that will be kind of awesome for a lot better and faster memory computational cost as well, better or reduce in the overall computational cost. Service without cache is like this: multi-application multiplication service over here as well. As soon you got cache, you'll just save it over here, and then at the later stage, you just ask it from the cache itself, cache memory itself. All right. What are some of the problems that you might consider by to cache your memory? Performance improvement, scaling. Performance improvement, obviously, it will be a lot faster. Scaling as well, because application can now does hold some of the frequently used or the frequently asked calculations as well in the memory. So that's why it will be having a lot more throughput as well, and lesser latencies compared to the earlier stage. Like if one particular person was asking some of the questions, then you might have had a lot of data in your own cache memory. So that's why you doesn't have to go over and iterate over each and every particular request that has been sent by each user, or the in a whole microservice application as well. You won't have to get over the request that has been shared, or iterate over the requests that have been sent by different services to perform different calculations. If any particular calculation or any particular requests answer has been saved into our cache memory, so we can just hand it over back to the user with a lot faster response. Resource optimization, scaling, convenience, and availability. You might have kind of predicted them all by yourself. It's nothing kind of new. Cache concerns, dealing with the side effects as well. All right, so what could be some of the side effects that you might consider while caching? Caching is an amazing thing, but still, what are some of them? Yeah, let's look into them either. Like for the caching as well, you should keep it in your mind that you might not like for thinking about any particular kind of the wrong things that might go along with any particular kind of problem. You might consider for which thing it was being built at the first place. Like for caching, we built it for the resource allocations, for better resource optimizations as well. So you might keep it in thought that you might not go along against the whole soul, yeah, or the reason behind which that particular feature was actually being introduced into your application or into your system. That is the resource optimization. So you might think, you might take a lot of different actions as well in order to prevent any resource overusage or the overhead resource consumption. uh, there are a lot of different problems that have been seen with the people who were, the whole usage of cloud as well. So yeah, it looks like there's some kind of problem again, or not. My Chrome might be showing. Yeah, it's fine. Google Chrome has a lot of problem. I'm like opening another window along with the grid so that I can see if there's something wrong that's been going on right now with the live stream. Right. So dealing with the side effects in our multiplication exam, reduce it. Ignore it. Compare this to a service that might perform some physical actions. Nah. Application of service is said to have a side effect if it modifies some state virtual or physical outside of the local environment of the application of service. Right. If it modifies some state, yeah, it's also another bad thing that you are saving up a lot of cache, so a lot of different users are relying on you. So that's why also while we were dealing about along with the static as well as the dynamic cache memory, I don't know if they have mentioned or not, but like the static cache was just a read only kind of a cache that we've discussed, and for the dynamic it is read and write as well. So that's why if any particular website, if you've saved let's say that the temperature of Jodhpur, like the place where I'm staying at the moment, it's is the average temperature in the month of December, it's, let's say it is 15 degrees Celsius. But after few years, let's say that due to the global warming or any other particular kind of reason, the temperature actually increases from 15 degrees Celsius to 17 degrees Celsius or 20 degrees Celsius. So you might have saved that particular temperature, average temperature, in your cache memory, because you might have searched it a lot. So that's why it will be saved as 15 degrees Celsius. But as soon you might see that the any survey or any particular website from where that cache has been saved, they have changed that the average temperature of Jodhpur isn't 15 anymore. It has been shifted to 17 in the month of December. So it will be changed in your dynamic cache memory as well. While on this static, it might not. You might consider deleting the last or the previous cache that was being saved in the early memory. I might say this one. No, it might not. Yeah, it might not have as much better resource management or the resource optimization. So it won't. Static one won't have as better resource optimization or the memory, lesser memory consumption. It's not real. Right. So yeah, let's we were dealing about with the side effects. So one of them was that the real reason behind the caching was that behind the real resource optimization, lesser overhead computational memory as well. So it has to be kept in mind, as well as also you are holding a lot of memory in your local cache memory. So that's why user or any particular application that has been using your cache memory, they usually rely upon the cache values that are being saved. So it's your responsibility that those values don't get corrupt, those don't change due to any particular reason, because of which the whole process that has been going around that data will also get corrupted. So it's a huge thing. It's a huge matter of concern. Software that stores data in the database has an external impact. It's changing the database of the database as well. Service that changes the position of a car steering, and it's these are some of the applications or the examples that I've been shown. I don't want to show that. Like those are good examples, alright, but still. Um, An application of the service is said to have its side effect if it modifies some of the state, virtual, or physical outside of the local environments. All right, so we might also consider in a multi-cluster environment or in a multi-service environment. What do you think, as a cloud engineer or any particular person? Uh, will it be fine? Will it be better thing to store your cache in the same pod? Or first of all, it shouldn't be pod. It should be node, I guess. Yeah, because in pod we usually should have a single image instead of having multi images, because it might, if any particular change that might have been pushed to the pod, it will affect both of the images that are being saved on it. Let's ask the internet. Let's ask if any particular blog has been written on it as well. If any particular person who's viewing my live stream, if they does have this answer, then I would love to hear them as well. All right, let's ask. Should we right, store our data? Yes, it isn't. Yeah, right. Yes, store our cache data. Yeah, obviously, it should be kept. It should be isolated instead of just mixing it along with the different files as well, because it might result if the if those particular files also get corrupted, or any particular change has been pushed to them, that change might also get implemented on our local cache as well, and that will create a lot of mess in the whole architecture. You might have to revert back the change that has been pushed to your environment, and then open up the other branch, and then retrieve it back, retrieve it to the earlier stage. Yeah, isolate data storage to each service, but a mix of caching strategies on both the same and different nodes, right? We should look into the docs or blogs that are being present over here, right? Caching unavoidably leads to a state of systems where some of its parts are seeing outdated data. They no longer preserve data strong consistency where guarantees and becomes eventually consistent. It's a price paid for the superior performance and resilience. All right, rule of thumb for microservice architecture is to embrace eventual consistency everywhere is so feasible. Strong synchronous coupling should be used only where it is needed. Yeah, if you'll cache each and every particular thing unavoidably, then it will. Yeah, first of all, it will have a lot of you might need a lot of memory management, as well as also it might hold a lot of memory as well over your data or different data that has been stored. You might see over outdated data as well as also if you try building the over ML models around that cache memory, because you will eventually, then it might also result in the outfitting of your model as well, where you'll get a lot of different. You might have entered a lot of different inputs for each and every particular condition that it will try, kind of contradicting along the whole reason behind the usage of that model. It might start interfering with the whole processing as well, and still it won't give like each and every particular change might trigger the values of your ML models as well to a lot different value, and that too won't be correct. So it's not a good thing. It's a price paid for the superior performance and resilience. The rule of thumb for the microservice architecture is to embrace eventual consistency everywhere it is feasible, and strong synchronous coupling should be used only where it is needed. Yeah. Invalidation of the items can also be triggered by the events. This is quite sleek solution, especially with the event-driven architecture. Or the original item changes, all the caching services could be notified by a message published by the data owner and eventually refreshes their cache as well. Invalidation of the items can also be triggered by the events. This is quite sleek solution. Yeah, even when architecture does hold a lot of different, they might trigger some of the problems. After the original item changes, all the caching services could be notified by a message published by the data owner, eventually refreshes their cache as well. Yeah, that's better. So that we might not have the outdated data that has been stored as a cache in our cache memory, and won't kind of contradict, or it might not overlap with the original or the current value of your status or of your data. Sometimes caching over services responses as is not an optimal solution. Instead, microservices can build complex data models derived from other data sources. They can gather pieces of information from various parts of systems and save its denormalized version in a local data store. and see if, yeah, right. They can get pieces of information. First of all, huge shout out to the Chris, the Atlassic. Huge shout out to this amazing technical writer, this amazing engineer. Let me get connected to him as well. I guess. Yeah, it could be meant as a huge shout out. Right. Hey everyone, there are four people. There is anyone who's watching it. I would love to read your comments as well. Let me know where you guys are from. And where's our blog? Here it is. All right. Microservice architecture, caching. Yeah. Let me share this as well. All right. I shared it as well. Now docs. Vision board. Bhavesh Verma. He's one of my college mate. He's my friend, my classmate. All right, so here it is. Yeah, it's eventually consistent. Eventual consistency. It's the end. It's kind of a summary to the whole blog. I might consider reading through going through the whole blog as well. It kind of looked uh, great. It ratio it. All right. Validation of the items can also be triggered by the events and time caching. Other services responses is not an optimal solution. Instead, microservices can be built and build complex data models derived from the outer data sources. That's exactly what I said just now. When it comes to the AI model training as well, that might cause a lot of problems as well. In case if there are a lot of over caching of different data as well as also and which might also include the outdated data of your system, because right now if you does still hold some kind of data from 3 or 4 years back, it might add a lot of confusion as well for your data, for your whole model. Might introduce a lot of outliers as well, or either the the overfitting as well. So it won't be good. At the end of the day, it won't be good for your model as well, for your AI model. They gather pieces of the information of the base or the systems and save it denormalized version in a local data store with an event-driven approach. Asynchronous messages can again serve as a way to communicate that the original data was altered. Yeah, we can think of it as another means of caching, but this time data has been stored persistently in querying services database. Wrapping up. Awesome. Come on. I'm gonna share it. Aryan email. Hope they won't. Oh, they ask for if I have a password. You know, yeah, maybe. Maybe I'm not a robot. Awesome. Never. Such way of communication, synchronous as I understand, also gave us some benefits. Most importantly, we always get the newest version of the data from the query services. Yeah, that's also kind of true. The data you received in response from the synchronous calls is already being. Oh, so they are considering about the synchronous data retrieving part. Um, let's have a look over there. This sentence, I just find it. Um, synchronous. Oh, come on, spelling is wrong, I guess. Misspelled it. Yeah, Redis. Um, yeah, cold and warm cache. In the memory cache of a newly booted process. All right, so here they are talking about the cold and warm cache. And the memory cache of a newly booted process starts empty. All right, so empty processes, those all are cold. It gets filled out only after the application performs a few reads and writes. We say that this way cache warms up. All right, yeah. So the whole query or the cache memory earlier it was kind of empty before any particular response has been collected into our that particular microservice. But as soon the applications start getting filled up with a lot of different cache that has been collected over the time, it might the cache start kind of getting warmed up. Because of that, a service might be a little bit sluggish on its startup and only after some time reaches a peak performance. Yeah, right. The solution to this problem is pre-warming. Return content to the cache asynchronously as soon the service boots up. The cache is that we don't always know in advance that what data should be cached. Right. And the problem can happen when the service is being scaled up to several instances. A running application process has an independent in-process cache, which inevitably leads to a solution where some entities are cached in one instance but not in another. All right. So while we are building the whole stack of the cache memory, at that time those caches are being built on top of some of the cache that has been, in process cache that has been stored in them independently. So that might inevitably lead to a situation where some of the entities are being cached at a lot, lesser time or in lesser wrong instances or cache misses as well in one instance because they've been trained in their whole model to save those caches without much of an error as compared to the other cases. To avoid this problem, we could use sticky sessions or sharding with consistent hashing. And even better solution is a standalone cache. Oh, it's yeah, this is an amazing caching blog. You might consider checking it out as well. Right. Um, these are some of the links. Um, we've learned different caching algorithms, not algorithms, but different kind of caching methods. Um, Static and dynamic caching. these are more inclined towards a general caching method, not even if your application is monolithic or even in the microservice application as well. So I might consider them of kind of labeling them inside the monolithic or microservice vision. Yeah. Um, yeah, here's the whole link to it. I don't want to share it independently. Monolithic, we had static and dynamic caching methods. Yeah, and for the microservice applications, I might consider it a blog to read. Um, something. Yeah, the blog was read it. We had cold and hot caching. Yeah, inconsistencies were based on what? Um, Due to the outdated over caching, over outdated cache, pre stored or pre, what do we call it, in process cache. I'm not sharing it. Pre-processed or in processed. This font text file is not right. In processed caching introduces you know inaccurate, not inaccurate, but um, gap, or introduce a difference between the cache processing of um, new and known cache types. I think I should, yeah, because it's holding some additional. And this one as well should increase the size, and boom. Yeah, this one as well. Anything else? Wait it. All right. Cache handling, monolithic and microservice applications. Let's have a look again. The blog itself. I'm going to stop this tree over here. We're going to read over the whole blog as well and over the PDF as well. We'll go through each one of them and get to know what we have, what did we, learn in the whole session. Origin board. All right. All right. Internet's kind of fine right now since a while. I think YouTube has some kind of problem earlier. Like before some minutes, right in the first 30 or 20 minutes, I got some kind of network issue. So that's why, for some reason, YouTube just kind of start showing up a lot of problems in the whole stream. As soon as I refreshed it, now I don't have as much of a problem right now. Core cache, standalone cache. We should also include, it could be solved by standalone caching. Right. Then we'll import as well. Perfect. Standalone cache is specialized infrastructure components shared amongst the application instances. It solves some of the problems described in the previous page. The cache is separate from the application, so its content is no longer lost after the restarts. Alright. Alright, so the standalone cache is, as the name suggests, it's been separated from the environments of the application environments and some of the other services as well, microservices as well that are being stored in of our application's code or some of the environments as well. So it will be shared or stored as a standalone cache. So the content is no longer lost even after the restarts, because as the application got restarted, you might start losing the memory as well. So if it was being kept in the same location with the other microservices as well. Since all the cache data is shared amongst the application instances, so we no longer need to worry about reaching the right node. Popular solutions for standalone caches are Redis and memcached. Alright, so great. So Redis performs standalone cache. Awesome. We've got another point. Standalone caching. As the name suggests, it's separated. Applications. Thus, it won't lost. Reduce memory even at restarts. Oh, no. By the way, what's the shortcut for jumping on to another line before, without reaching out to the end of the line in Google Docs? Like in the VS Code, I guess it is Control plus Enter. In case of the IntelliJ ID, we had Shift plus Enter. Shift plus enter is kind of a shortcut to go to the next line without just entering or sending your requests. Yeah, shortcut for jumping Google Docs. Control plus Alt plus N. Yeah, now कौन करेगा? Shift plus Enter. No, it is not. Anyways, standalone cache. Alright, so okay, so in case of standalone caching, all the data usually reaches out to each and every particular application's instances, or yeah, applications instances that has been stored in our environment. So that's why doesn't have to worry about either which kind of algorithm do we have to worry about or adopt to our environments in order to send our packets or this whole data or the right node where our requested service is actually being hosted, um, shared amongst all the application instances. Thus we don't have to worry about prison. Oh, come, don't have to worry about the yep, packets. So that was some of the points about standalone cache. Let's have a look. Public solutions, yeah, this one as well. I'll have to mention it. Popular solutions are Redis and cached. Come on. Standalone cache can become a single point of failure. It runs in a single instance. Oh, I jumped too far. Right. And our more specialized variants like in-memory data grids, for example, Hazel, Cast, and Apache Ignite, which in addition support performing distributed computations on the stored data. Oh, that's awesome. Sometimes the amount of data we want to cache is way beyond the capacity of a single machine. Sometimes the amount of data we want to cache is way beyond the capacity of a single machine. By employing sharding, we can save terabytes of data in the memory of multiple nodes. Alright, this kind of sharding is transparent from the application's point of view. The cache is responsible for routing the instance holding the right entry. Right. Standalone cache can become a single point of failure that runs in a single instance to achieve high availability of the system. The cache component should either run as a distributed cluster or have failure nodes and failover nodes as well. Yeah, right. Because if our cache environment, if our cache instance would be running over a single, single container or say a single instance of our application, then it might add up a lot of different vulnerabilities as well. Because if it gets corrupted, then you like in the Kubernetes, in a lot of different environments and with a lot of different solutions that are available at the moment. You might have heard about the GitOps approach as well. So in that scenario, if let's say if we have a single instance of cache, you won't have another a reference from where you can just check if your instance haven't got corrupted. Because if you will be having a lot of different replicas as well of your same cache memory of your cache instance, then they can actually help you in assuring that your data haven't got corrupted. Or even in case of a server going down, in that case as well, you can just quickly scale up or schedule the replicas of the cache memory that has been stored on your environment. Like for the from the security purposes, for the scheduling, or in case of any the node failure, it might be a great reason to just have replicas or distribute your caching memory as well. But also in case of the security, to save yourself from such kind of the network or the node failures, you can just hold the status of your cache in in a different file to uh, describe how it has been structured. And then later, if any particular you know if any particular problem might have been posed to your caching memory, then you can just check it and revert it back in case if the other replicas aren't same as the current status of the replica of your cache memory. So it might add up a lot of security insights as well. Right. So let me add it as well. Our docs. And don't correct me. All right. So what we have on our mind? Yeah, single instance. Um, Problems. A single instance might add up the vulnerabilities to our cache memory, and single point of failure as failure, because with the distribution of our cache memory, multi instances over the cluster can help in handling security, node failures, and monitoring as well. Yeah, because you might bind all those different cache memory as well over a chain, and if anything wrong happens, that chain might get broken, and you can just instead delete or terminate that particular instance and just add the replica of that particular instance with the chain, and just uh, not a chain, but like you get what I'm saying. If those all are getting connected through the APIs, and then it might be a lot better. So yeah, let's get back to our doc. Support for both clustering, Redis cluster, and for promoting replicas in case of node failure. Yeah, as I said, Redis cluster Clustering as well as also for the node failure. Clustering means there are multiple instances that has been deployed on your architecture. That's why you might need a lot of different solutions as well as uh, troubleshooting parts for your clustering as well as also for the node failure. If you have just decided to have a single instance of your application, in that case, you should have a node failure kind of function as well, and so that it might just terminate the whole instance as a node failure and might not create a lot of problem or corrupt the data that has been stored over our cache memory. Redis has in cluster, what do we call those solutions? Redis cluster, support for Redis cluster. Clustering and node failure. Redis cluster and Sentinel. This cluster and Redis Sentinel. Right. So running while the load balancer in my cache, microservice A, microservice 2, instance 1, instance 2, and it will be turn them out to the microservice B. Standalone cache don't necessarily needs to be deployed as a separate component in containerized systems like Kubernetes. It could be run as a sidecar. Oh, that's awesome. Sidecar contain, yeah, it will be a lot better solution to run it to run the cache memory as a sidecar. But also, I've been working along with this sidecar architectures as well. It might be a nice, like standalone cache. Like standalone cache will be better to kept in a service entry. I might won't agree to this particular line because in case of the sidecars as well, if you does have some of the replicas as well that has been stored of your cache memory, not as for the Redis Sentinel, like if you does have a lot of different replicas, it will be a different story because if you just want your cache to be near to the main cluster that is holding the whole environment or your whole model, then it could be great idea to put it in the service mesh or the sidecars. But sidecars can't be believed so easily because at the moment sidecars have been also having a lot of security threats, as well as also they are having a lot of problems because people have been switching. People doesn't know how to switch between the layer 7 of telemetry or either like even if you want sidecar, yeah, sidecar might work, but I won't suggest you to adopt service mesh. Instead of that, you might adopt the ambient mesh because it will be a lot better solution for you as well. In that case, yeah, that's great. That's great. I might store it. It's like I can contribute to this project that they have for this particular thing. Yeah, standalone cache manage and with sidecars, but with ambient mesh instead of handling with service mesh. Yeah, that's kind of an awesome thing. Great. This blog gave me an idea. Awesome. I can adopt it and present it maybe in the community as well of K Gateway or either the Istio as well. Awesome. Let's share it. Random caching can be deployed with sidecar models in case Kubernetes. But um, consider choosing the, the best, most precise service mesh, no, precise mesh model, service or ambient mesh. Right. It didn't got awesome, no problem. Great. So that's awesome. Thanks, bro. Thanks. Yeah, that is an amazing idea. I would love to work more on this particular thing. We'll try to research a bit more on which one will be a lot better for any particular solution that has been deployed, like for handling the cache. I mean, on the other hand, it gives you access to all the features of midway solution between the full-fledged distributed cache server and in the standalone, I guess, right? In a nutshell, it's midway solution between the full-fledged distributed cache server, full-fledged. All right, but was it different? Distributed cache server. All right, but in memory, couldn't be same. I don't know. Disadvantage of having a cache as a separate component is that it needs to be accessed by a network, and therefore it will never be as fast as the in-memory variant. So yeah, that's what I'm saying. Like just if you want, I still if it won't be different because the service mesh, like in sidecars, you might have service mesh, but it will add up another layer of the complexity because it will be handling over the L7 layer of telemetry. Because yeah, for each and every particular component of your Kubernetes application, even for different instances as well, you might have some kind of sidecar being added to your architecture. And over there you can work very closely to the service or the the application that has been working at the moment of your application of your component, like any particular user who's been on, let's say, on Amazon or on the Amazon.com instead of or let's say if any particular person is on the Amazon.in of Amazon.com, that whole domain, top layer domain, um, even within the Amazon.in, if any particular person has been messing around with the cart of particular users. So that's why it will be having a lot of different, fragments of the survey that has been going on at the moment for the transaction. And then within the, you can even have a sidecar being deployed along the for that different component, and then you can play around. But still it will add up a lot of complexity as well for your application. So for like, if you, yeah, that is disadvantage. That's what I was saying. Huh. Um, like ambient mesh can provide you lesser complexity, but it can work along with nodes as well as also for the namespaces as well. It will create lesser uh, complexity. Still, I'll need to check it, because even within the admin mesh, you have ztunnel as well as also your waypoint proxy. So there are different things that you will have to consider before going along with any particular path of choice. So let's have a look. Cache expired and invalidation sidecar. Yeah, that's what I was saying. It will never going to be as fast as, but still let's kind of add. But in case of sidecar, not sidecar specifically, he didn't specifically mention about the sidecars, I guess, right? Separate component, that's all what he said. In case of separate component, uh, it will be added as via a network. So can never be as fast as an in-memory cache. Yeah, it's kind of true. It can't be as fast. Cache expiration and invalidation. After some time, data in the cache will inevitably drift apart from its source, using for the users TTL, right? Yeah, that time to live and a lot of different things will be coming up in that particular book as well, because these are some of the most basic things that you might heard while ending along with the caching of your data. So yeah, even if there is any particular Golang developer as well, then then too you might consider, it's very amazing, because the Golang developers ought to, solve a lot of API related problems and handling out the microservice architecture as well. So it might be a great idea to consider um, the whole system design as well of this particular thing. So yeah, the most straightforward tactic for getting rid of the stale items for the cache is based on time. Uh, Time to live, yeah, that those you might have heard about it in the OSI model as well. Time to live, like even in the doing a three-way handshake as well. At that time as well, you might have heard about the time to live TTL as well. So yeah, that's kind of very basic kind of thing for any engineering class in the network session, while handing along with the transport layer of the HTTP and UDPs. That layer, at that point, you might have heard about it, either at the HTTP level. Yeah. Most straightforward tactic for getting rid of the stale items in the cache is based on the time. We need to simply define time to live for the items inserted in the cache. After the elapses, the item is purged. If there's another request for the item, it gains fetched from the source and then cached again. The process is then called as this cache injection. All right. This approach has some flaws. It queried data is if queried data is changing unpredictably. For some entities, it's more dynamic. For some others, it's static. It could be changing. It could be challenging to come up with the right value of TTL for TTL as well. Right. If you set up TTL as the too high values, we will be often serving scale data, and if it's too short, we'll be affecting items from this cache faster than it's necessary. Moreover, after the eviction, the item is removed from the cache. The next request for that entry will have to do a potential slow network round trip to fetch it again. Yeah, that slow and warm cache memory as well that we have learned earlier. Let's place it over there as well. Oh, am I not sharing it? My screen. Very sorry for that. All right, so they were talking about the TTL, that is the time to live for any particular cache that has been stored on our cache memory. Let's say if our we've been fetching data from any particular website over a fixed interval of time, like through the real approach. That's what I'm saying. It's been catching some of the data. Let's say it's been keeping an eye. It's been monitoring the markets, or the share markets, of the whole world. So at that time, let's say the share value of any particular stock is X, but in after some time it changes. Then the fetching will start for your application or for your cache memory, and then if any change has been occurred to that particular value, then it might retrieve it and delete the older or the earlier memory or the value that was being stored on your cache in order to resist any particular kind of the confusions within your application. So it's kind of a confusing thing, because in the time to live, that is TTL approach, you might set some kind of a value for your architecture, for your application, for your backends, and let's say even like we don't know that the market is stable or either it is unstable at the moment. But it's stable, then you might not get as much difference within the shares value. Whatever is unstable, like it's really unpredictable at that moment, because if you have set the TTL value, which has been a value of the time that has been set by you in order to check that or fetch the data of any particular value that has been set onto any location or the endpoints, and if it does has any change, then it might upgrade. So if the TDS value is too high, then you might get a lot of stale data, and you might have taken too long, and the value have just changed dramatically of any particular item. But if the real value is too smaller comparatively, then you might be fetching data for no reason, where you might have just gone through a standard value. Like you might, because if any particular value has been fetched and the earlier one has been deleted from the environment, then it might start from the cold kind of a cache memory, and it might take a lot of time as well to get it warm and get it functioning truly accurately and precisely. So that's why in that particular kind of scenario, that's what I'm saying, that this approach, that's what the person is the writer has been saying, that this approach is not as correct or precise. Great. Let me change it or our tabs as well. What it is? Yeah. Popular solutions. Nope. We were talking about just now the TTR, right? Yeah. So it is a problem. It is a problem. You need to write it. You need to mention it over here, and below them popular solutions. No. I think we should mention it over here as well. Components in case of separate components. Yeah. Um, Remove it. Get over here. Right. And huh, TTL, time to live, for fetching updates and replacing them in cache memory might introduce inaccurate, no, unprecise data. Precise data because it's too high. TTL, if it is too high, then um, you know what should be the better language to write over here? Be often serving stale data. Yeah, shares stale data. If too short, if it's too short, then unnecessary, unnecessary quick fetching and processing of data. Yeah. Right. To avoid the problem, you can refresh cached entries periodically by a scheduled job. All right. You just refresh the cache entries periodically by a scheduled job. This is a great way to avoid the latency spikes when a hot cache item is created. The approach is called refresh ahead. The drawback is that the data is not changing very often. We'll be doing many redundant requests. Yeah, so how does it solve? Drawback is same as the earlier TTL as well, because like the TTL has two kind of problems. If it is too high, then it was some of the problem. Otherwise, it's just doing the same thing as if it is if the TTL has been set to low. You could also try to make a cache refreshing procedure a little bit smarter. First of all, queried service should return some hash code calculated from the return data. Queried service, right, should return some hash code calculated from the return data. The recipient could store the data in the cache along with the hash. I can, I can make it. I can try making it, and then integrating in my own project as well. The recipient could store that data in a cache along with the hash, and from now on include it in every request for the same item. Include it in every request. Which service can now use it and check if the data has been changed or not. If it didn't, then the service could just simply return. Oh, that's awesome. That's kind of a lot better. Yeah, but still we usually have very lightweight. It won't interfere along with the the main processing that has been going along at the moment as we being standard. The standard has dedicated mechanism to do this optimistic caching e-tag header, but it can easily be implemented with other means of communications like G. Oh, come on, yeah, that's awesome. gRPC, I can easily apply it along with the gRPC through the Golang. That's awesome. Yeah, refresh ahead. Let's change it. TTL refresh ahead will अरे यार क्या स्पेलिंग है इसकी optimistic caching, what do we call it? Query service. Hashing, इसको बोलते क्या है? The value of the database will get the newest version of the item. So this only applies to the instance that does save. Single item reader nodes will still need to invalidate their content by other means. If we are using a distributed cache, it's also not a problem. E-tag header. Um, that's what we call it, I guess. E-tag headers, right? Duplicate it and how do I add it? Things ching, right? TTL and all. These are just kind of problems that you might have seen. So I should get rid of them in a separate section instead. Not because they are not a part of the standalone, right? Yeah. Awesome. E tag header. Optimistic cache. Not caching, but optimistic updates. Cache update. In contrast, if we update the in-memory caching using writes, we have guarantee that then reads will get the newest version of the item, but this only applies to the instance that does save data nodes. We still need to invalidate their content by other means. Alright. Alright, so that was all about the whole um, microservice caching. That was all about the monolithic caching as well as also about the microservice caching. We took the reference of some of the blogs as well as the talks that were available over the Redis and or some other blog posts as well. So we'll continue it. We'll try to read through the whole documentation as well as also we'll try to get along with some of the other features as well that are available at the moment, and then later we can kind of build our own project as well. We'll be making a project, project that has been inspired by the Redis itself for an in-memory kind of a database that has been handled. But I'll be making it or kind of integrating the caching, cache handling as well, and that too I'll try to integrate this um, the e-tag handler along with it because it is a lot better because it will be handling, it will be um, including the hash values as well, and the hashing different values as well, and going around with them to over to the side of the source that we've been referencing to at the moment, and yeah, it will be kind of an amazing thing. So we'll try it. We'll yeah, that's all. Thanks a lot a particular for a particular viewer who was present over here for this live. We'll try to have another live stream soon for you know um, for you know understanding about the whole caching and a lot of other things as well from the Redis itself. So we'll try to even look into the data ingestion layer as well of how Redis performs it. It's been going and handling along with the single thread. There is also an amazing thing. So we'll try to get over the whole functioning of Redis with the single thread as well, because the multi-threads, they often provides a more complex kind of requests handling, but tend to even with just a single thread, they are able to produce a lot better kind of a solution in their environment for their customers and users. So yeah, that's all. Thanks a lot. Radhe Radhe. See you next time.